And the distance formula is, well, it says this. It says that it is a formula. So a formula used to find the distance. It's a little bit repetitive here for this first part of the sentence. To find the distance between 2 points on a coordinate plane. So it's a formula used to find the distance between 2 points on a coordinate plane. And here is what the distance formula actually is. We're going to definitely write this down in our notes and use it a bunch today. And it is this right here. So we got d, lowercase d is equal to, and then you're going to make yourself a big old long square root symbol, because we're going to put a whole bunch of stuff underneath this square root symbol. So d for distance, distance is equal to, and then we got some coordinates. So we're going to do parentheses, and then we're going to write x, and then this is called subscript, where you got the little 2 down by it. Kind of like when you learned about the slope formula last year, right? Where you had like x2 minus x1 over, or sorry, y2 minus y1 over x2 minus x1. So put the little 2 down below it like that. So x2, that would be the second x coordinate, minus x1, so you're subtracting the first x coordinate. Close those parentheses. And then that difference, that subtraction, is squared. All right, then plus, open up another set of parentheses. Now we're going to do the same thing with the y coordinates. So it'll be y2 minus y1, close that parentheses, and then square that as well. Now this looks pretty complicated. The nice thing is that every single problem that we do, we're going to be given values for x1, y1, x2, and y2. And all we're going to have to do is basically take our calculators and plug into this on our calculators and not necessarily have to do anything by hand. So as long as you're able to type that in with the numbers that you need, it'll be fine. So let's go ahead and switch over to the actual notes. We'll get started on that. So topic, distance and midpoint formulas. And today is August 31st. Tomorrow is September 1st. Getting back to like the actual month that school starts, right? Not used to starting in August, really. I think it happened last year, but doesn't happen all that often. Okay, so the formula, we already wrote this down. Let's write it down again. We're going to say d for distance equals, here we go, big, long square root symbol. And we've got x2 minus x1, and that gets squared, plus y2 minus y1, and that gets squared. And that all happens underneath the square root. Okay, so first thing we need to do is figure out the coordinates of the points that are on our graph here. So we need to figure out coordinates of this point right here and the coordinates of that point down there. Based on what you remember about locating points on a graph, anybody tell me what the location of this one is for the XY values? -5 and what? 3, yeah. So remember, when you're finding points on a graph, start from the middle and then use your X coordinates first. And if you're going left, that would be negative. We can see -4 is here. We're going all the way over to -5. So that would be -5. And then if we go up to this point here, we're going up 3. So that would be left 5 up 3 would be -5, 3. All right, so if we use the same logic on this one, we're going left 2, so that's -2, and then down 3, so that'd be -2, -3 for that one there. So -2, -3. All right, so the 2 points that we have, we're just going to write these over here real quick. We've got -5, 3, and we have -2, -3. Now, in terms of the values of x1, y1, x2, y2, it doesn't matter which is which. This could be x1, y1, that could be x1, y1. It doesn't actually matter. Basically, just stick with one and go with it. So if you wrote this one first, you could use that as x1, y1. It doesn't make a difference. The math works out the same however you do that. So I'm just going to say -5, that's x1. 3 is y1 because it's the first x value and the first y value. And then x2 would be the second x value and y2 would be the second y value. So those are our x1, y1, x2, y2. And so we're just following the directions over here to the left, by the way. Find the distance between the 2 points on the graph. That's what we're doing here. And then we can just go ahead and take those things and plug them in to the distance formula right here. So we're going to say d is equal to, and then make your big, long square root symbol. And for those of you who were in my Algebra 1 class last year, whenever you plug in for a value, substitute in for a value, how do I always recommend writing that, especially with the calculator? Anybody remember? From my Algebra 1 class last year? Parentheses, yeah. Plugging values into parentheses will, especially if you're using a calculator, guarantee that the calculator will give you the numbers that you want. If you leave off parentheses, there is a chance, and oftentimes a good chance, that the calculator is not going to display the correct answer. So try to make sure that you're going to use parentheses anytime you plug in for a value. In fact, I'm going to go ahead and just put parentheses around these things even in the actual formula. So I'm going to put parentheses around x2 and x1 and around y2 and around y1. So there's going to be a lot of parentheses happening here. But the reason for that just means that when we type it into our calculator, if you just type everything in, it will actually, your calculator will understand that sometimes a little bit better than if you leave them off. So I always suggest anytime you substitute in for a value, put that value inside parentheses. So we're going to have our large set of parentheses. So this is kind of like containing both of our x values. And then within our first set of parentheses inside that, we're going to write the value of x2, which happens to be -2. So there's -2. And then we can close that small set of parentheses. And then in between x2 and x1, we have a minus. So I'm going to write minus. And then we're going to subtract the value of x1, which is right here. It's -5. And then we can close that small set of parentheses. And outside of that, we have the larger parentheses, and then everything there gets squared. In between the two large sets of parentheses, we have a plus. And then we open up our second large set of parentheses, and then within that, we're going to have a small set of parentheses with the value of y2, which is -3. We'll close that little one. And then we're going to subtract from that the value of y1, which is 3. And then we can close that large set of parentheses and square that as well. Now, for this first one, we'll kind of just talk about doing this step by step, but then I'll just show you can type this in and get the answer straight away. So let's have a look here. So -2 minus -5. So if you want to, you can just start by typing that into your calculator. We'll get the whole thing typed in just a minute, but you have -2 and then you subtract -5, kind of like that. Oops. That one needs a parenthesis. There we go. And that gives us 3. So -2 minus -5 is 3. So the math inside this set of parentheses equals 3. And then it tells you to square it. 3 squared doesn't mean 3 times 2, it means 3 times 3. You multiply the thing by itself. What is 3 times 3? 9. Okay. So all of this here squared equals 9. So we're just going to write d for distance, and then under there, we're going to write 9. Because that first set of parentheses squared turns into 9. And then for the other one, we're going to have -3 and then -3. What does -3 minus 3 equal? -6, yeah. Now, here's another thing where using parentheses on a calculator really matters. Without the calculator, you could probably all tell me, what is -6 times -6? 36, right? Positive 36, yeah. What happens if you type that and square it on your calculator? And use the squared button, I mean. So if you type in -6, the squared button is right next to 7. It's the one that says x squared. So if you type in -6 squared, what does your calculator show when you do that? It says -36, which is weird because that's actually correct. Might not seem correct, but it is. Because the problem that we actually want is that one with -6 in parentheses. That's actually a different problem. This is a different problem than that. And when you type this in with parentheses around the -6, what does your calculator tell you? Go to try that out. 36. Yeah. So those are two different problems. The reason for that is your calculator is taking -6 and then multiplying it again by -6, because you're squaring it, and you get positive 36. Here, it's taking 6 and squaring it to get 36, but then it's taking the opposite of that afterwards to get -36. So this would be the opposite of 6 squared. Squared, and then apply the negative. It's using order of operations, which seems a little funky, but using these calculators, whenever you square a negative number on these calculators, and it's kind of just, this is the practical part of this. Anytime you square a negative number on these calculators, put that negative number in parentheses. That way you can get the positive answer that you know is correct. All right, so we got positive 36. So under the parentheses, we're going to have 9 plus 36. What's 9 plus 36? Add those two numbers together. What do you get? 45, right? Okay. So the distance is equal to the square root of 45. Now, the square root button on your calculator is the green paint above x squared. So to get to that, in case you don't know, you're going to push the button that says second, the green button up at the top left, then push x squared, and that will open up your square root. So green button, second, followed by x squared, which is next to 7. And then type in 45 for me real quick and hit enter. And then what does your calculator say? Probably just says square root of 45, huh? Or 3 root 5, which is a simplified version of that square root, but it still doesn't really help us in terms of knowing what that actual number is equal to. So what we're going to do is we're going to round this to the nearest 10th, the nearest single decimal place. And does anybody remember how to go from like exact answers to decimal approximations on this calculator? Anybody remember that process? Good thing is it's super easy. The button right above enter, this one here, the left right arrow, push that button. There you go. So the answer is approximately 6.7. So we're going to say D. Don't write equals. We're going to say approximately, so squiggly equals, is about 6.7. And that is our answer for our first example. A lot of these, most of these, in fact, are going to be turning into decimal approximations as opposed to whole number values. So the distance between those 2 points on this graph is about 6.7. Cool. All right, let's go to problem number 2. So this says find AB. So problem number 2, find AB when A has coordinates of -4, 1, and B has coordinates of 3, -1. So point A is at the location -4, 1, and point B is at the location 3, -1. And what that means is find AB just simply means find the distance between those 2 points. So it actually tells us what the 2 points are this time, which makes things pretty convenient for us. So we've got x1, y1, x2, y2. And this time, let's just go ahead and type the entire thing into our calculators instead of going step by step. Because your calculator can handle doing everything all at once. So let's do that. We're going to have distance is equal to, here we go. Line it all up, get your long square root symbol going. And then we're going to have our large set of parentheses followed by a small set of parentheses with the value of x2 inside of that, which happens to be 3. And then you're going to close that off. And then we're going to subtract the value of x1, which is -4. Oops, that was supposed to be blue. -4 inside that. And then we'll close it all off and square it. And then we're going to add to that the value of y2, which is -1, minus the value of y1, which is +1, so -1, and then 1. Close off the smaller one, close off the larger one, and square it. Okay. So what we're going to be able to do is just type all of that into our calculators, and it'll give us an answer right away. So let's get our calculators ready. Go ahead and write that down on your paper there. Scoot this over so you can see the calculator. Put that up. There we go. All right. So first thing we got to do here is open up our square root symbol. So that would be the green button again, second, followed by the x squared button, because everything we write is going to be inside that square root symbol. All right, so we're going to start with parentheses, followed by another set of parentheses, and then 3, and then close one set of parentheses. Then we got minus. And then we've got ourselves another set of parentheses to open. Oh, by the way, please remember that the minus and the negative buttons are different on these calculators. It's not the same button. So if this is a minus, the symbol next to the 4 is a negative, and the negative is down by the decimal. So if you hit minus with next to that 4, it's not going to recognize it. So if the number is negative, push negative, and then 4. And then we're going to close that set of parentheses. And we're going to close the bigger set of parentheses. So lots of parentheses happening here. Then we need to square that. So once you've got that, push the button next to 7, which is x squared. And then we've got it squared. Now we're going to do the same thing again, but with the y values. So scooting over here. Don't forget the plus, though. So plus, and then parentheses, and then parentheses again, -1. Close that one, minus, parentheses, 1, and then close both of them, and then square again. If you hit enter and it says syntax error, that means that something wasn't typed in correctly. If you hit enter and you have an answer, hopefully square root of 53, then things went well. So we're going to say d equals the square root of 53. And in order to get our approximation, we have to push the button above enter. And when we do that, it says 7.28. If we're rounding to the nearest tenth, though, the rounding to the nearest single decimal place, is that going to stay at 2? Or is it going to go up? It's going to go up. Why? The number after it. Yeah. So I know we don't do a lot of rounding anymore, so that's why I'm being, pretty careful about this. Anytime you round, remember you have to look at the number after it. And if this number is 5 or more, this number goes up by 1. If this number is 4 or less, this number stays the same. So 0.28 rounds up to 3. So this would be D is approximately 7.3. That is the distance between those two. All right. I want you to try problem number 3 on your own. And I believe this is the last one. Yeah, this is the last one we're doing today, by the way, in our notes. So just 3 examples today. So I'd like you to try problem number 3 on your own. Take, 3 or 4 minutes. Feel free to, if you got somebody near you that and you want to double check, work with them through this problem, feel free to do that. And as soon as we're done with that, I'll get you your assignment. We should have a decent amount of time to work today. And at that point, you can move around and work with people and group the desks up and all that kind of stuff. So, and of course, if you're working through this right now and you have questions for me, please ask. I'm happy to help. For today? What did you get for your answer? Okay. And you are only working through problems 1 through 5. Okay. So it'll be x2 minus x1. Yeah. Yeah, this one actually works really well. Yeah.
How do you get this?
It's right here, but it's part of the formula. Yeah. Oh, I can check. Yeah, nice job. Cool.
So we got this. What do we do now?
We're going to do this.
Oh.
Yeah, number 2. Yeah. Looking okay? Maybe try this one actually. Okay.
Want us to close it?
What's that?
If you want us to close it,
Okay.
can get from Steve.
Yeah, so let's see. You got 1, 2 going this way, and then a third one there, right? So you got 1, 2, 3 going the same direction, then you've got 1, 2, 3 going the same direction. So as long as the amount matches up, you're good. I'm going to scroll back here real quick and make sure that that gets squared though. And then plus. Cool.
What do I do with the next one?
Keep going. Use the y values and subtract them.
Push it around, add the 2 on the right.
So you'd have y2 minus y1 in the second set.
Yeah, what I do for it, but I have them on
Same
the
thing.
left or the right.
Same thing as what you did here. It'll look exactly like that. Yeah. So you do 2 open ones and then the number, yeah, just like you did. All right. All right, so we got x1, y1, x2, y2. Let's go and take a quick look here. So we're going to have distance is equal to I'm not going to go with different colors this time. So let's see, x2 is 11 minus x1, which is -7. We'll close that up and square it, plus y2 is 3 minus y1, which is -2. We'll square that. Okay, so let's see. That would be plus, all right, that's interesting. So 11 plus 7 would be 18 squared, which is quite a big number. So let's just go ahead and just get this whole thing typed in. Anybody have an answer for this one, by the way? 18.7-ish? Yeah, about 18.7. Cool, I see some nodding, that's good. I like that. 18.6? Oh, interesting, let's find out. So I'm going to type this all in. So we're going to have 11 and then minus -7. We'll square that. We will add. Let's see, that's a 3. That looks like a 5. That is a 3. Minus and then -2. So it ends up being the square root of 323, right? All right. And whoa, that's not right. Should be 18.7. I messed up somewhere. Hang on. X2, 11. All right, minus X1, which is -7 squared plus Y2, which is 3, minus Y1, which is -2. There it is, square root of 349. Okay, I don't know what I typed in wrong, but I typed in something wrong. Okay. And that's converts to, so the 0.6, so imagine the 0.6 has an 8 after it, so this 8 would round that 6 to 7. That's why, yeah, so you did it exactly right, so nice job. All right, so D is approximately 18.7. Nice. Very good. All right, so we're on a normal schedule today, so that means we're out of here at 9:13, I think, which gives us about 20 minutes of work time today. That's awesome. So I'm gonna get your assignment to you, and the nice thing about today's assignment is you only have to answer the first 5 questions. Because all of the other ones on here have to do with midpoint stuff, which is the rest of this lesson, which we're not going to do until Tuesday. So I'm going to hand this out. All you need to do is answer the first 5 questions. If you finish the first 5 questions, you're free to just kind of sit and chat and enjoy the rest of your first period without having to do much work. So